Alright, this lesson is going to be on finding Pearson's correlation coefficient, which is R. So far, do you agree that all that stuff that was on the previous boards, is there any maths to that? Is there any numbers on that? No. So what we've done is not very mathematical. But there's two important aspects of correlation out of those five. Strength and direction. We can actually represent that with a number. That number is called Pearson's correlation coefficient. The code for it is R. Small r. This is a number that ranges from -1 to 1, and then 0 is right in the middle. The sign of R tells you the direction of the correlation, positive or negative. And the size of R, how close it is to 1, tells you the strength of the correlation. So for our purposes, if you've got your textbook there, I've put a screenshot of it. On page 84, use these words to describe the correlation when you found the R. Could someone explain to me why I only need you to note down one side of this to save space on your cheat sheet? It's just the opposite. Why waste a giant section of your cheat sheet drawing both sides of this when the only difference, what you want to know is that if R is 1, that's a perfect correlation. They sit exactly on a straight line. When it's 0, it's random. When it's 0.7 to 0.87, it's going to look sort of like this. The reason why you should have this table is because that's sort of what SACE accepts. If it asks you what is the meaning of R when it's 0.9, they expect you to say, well, it's a strong positive correlation. How did I get that? Because it's 0.9 between 0.87 and 0.95. So just look at the table. Don't leave it up to in the air. Why do I ignore the right side? Because this is just the opposite in the negative direction. Okay? How do we actually find R? So I'm not going to give you time to copy this down. You can do that in your own time. Okay? I've just told you that that's what you do. Can you get your graphics calculator out now? Because you're going to do this over and over. Did you use TVM Solver over and over again in finance? Yeah. So there's an app here that you're going to use over and over again for statistics. We can find R ourselves using our graphics calculator. To do this, why did I say fist? To do this, that's in the YouTube video. To do this, you first need to know, how do I enter data into my graphics calculator? Casio users, you don't need to do this first step, so just ignore. On your calculator, if you have a Texas Instruments, you need to turn diagnostics on first. So what you do is, on the calculator, can you sit at the back, please? There's a video going. You go second. Can you see above 0? What does it say in blue? Catalog. This is like all hidden hacker settings of your calculator, okay? We need to go to a setting called diagnostics, but I don't have friggin' time to scroll all the way down to D, okay? So just so that you know that there's a shortcut, can you see how over the X to the -1 button, there's a small green D? If I press that, it skips straight down to the D stuff, so I don't have to press down over and over again. So you need to make sure that this Samsung is freaking out. Don't buy Samsung, people. That's on YouTube too. Diagnostic on. You press enter. You haven't turned them on yet. You need to press enter again. Done. Diagnostics are on. Because we need diagnostics on to find out R. Now, how do we do statistics? To actually enter independent and dependent variable data into a calculator, press stat. Can you see the stat button there? Stat. Select one edit, press enter on there. Does this look like a table to you? You have lists all the way. There's multiple lists on your calculator. Your calculator's data lists have appeared with headings L1, L2, L3, etc. You enter data into this list by typing numbers and pressing enter after each. So I'm going to type 1, 2, 3, 4, 5. 1, 2, not 23. 2, 3, 4, 5. If I was to graph that, what would the scatter plot look like? It'd be like a perfect 45-degree line. It'd be like that. So if we know ahead of time, what would R be then? If it should be 1, okay? So we put that in. That is how you enter data onto the graphics calculator. I am turning diagnostics on a step in doing that because some people use the school's calculators. You don't know if diagnostics have been turned on before. If you're using your own calculator, it's going to stay on. But, because I know a lot of you this year don't have your own, you're going to have to just turn it on always, okay? Now, how do we find R? Make sure you've entered your independent and dependent variable. Have I entered my data here? Press stat again. So I've entered my data. I press stat again. Can you see calc at the top? So select that with your arrows. And then you scroll down to number 4, lin-reg. That button's lin-reg means linear regression. What the calculator is trying to do is fit a line to your dots. It's going to be a perfect fit. We know that because we made up the data. So you press enter on lin-reg. And this is telling you, this is where I'm finding my X data in list 1. This is where I'm finding my Y data in list 2. Make it a habit, you always put your X data into list 1 and list 2, so that it's just quicker for you, okay? You leave frec list alone, leave that empty, leave store reg EQ, leave that alone completely, and then you go down to calculate, and you press enter, and this pops up. The following appears, lin-reg, y is equal to ax plus b. Do you remember in topic 2 we did line equation? That's a slope-intercept form of a line equation. This is telling you what a is in that equation. This is telling you what b is, the y-intercept. Is r exactly 1? So that sort of confirms that our data that we just put in, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It's going to be a perfectly straight line. That correlation is going to be perfect. If I change this to 3, is it going to be perfect anymore? It's going to be 2. It's going to be like, one of them is going to be a little too high. So what do you think R is going to do? It's going to be 1 or is it going to be less than 1? Is it still going to be positive?
Yeah.
Yeah. But it's not going to fit perfectly. So how did I find R? Stat, calc, lin-reg, enter, confirm my X data is in list 1, list 2, scroll down to calculate. It's not perfect anymore. Okay? Before I stop the video, and so that I can show you as well for your benefit, I'm going to turn diagnostics off to show you what you can do if you use a not your calculator for the exam. So let's pretend your calculator ran out of battery during the exam. You're using a fresh one from the school. You put your data in, stat, edit, stat, calc, lin-reg, calculate. Can you see how there's no R and R squared anymore? Because the diagnostics are not on. Okay? So do you see why I made that one of the steps in putting data into your calculator? Just turn it on. So whenever I turn my calculator on, I go second, catalog, scroll down to the D's, diagnostic on, answer. They're gonna strike my video down, aren't they? 3 strikes. Near diagnostic on, done. I'm gonna do the exact same thing. Stat, calc, lin-reg. Now it's back. Don't ask me why those are Texas Instruments. I don't know why the Americans decided that that wouldn't be useful information. Now the Americans are going to strike me down on my YouTube, whatever. Okay? But does that show you how you find Pearson's correlation coefficient? So you're going to have a number of questions in 4C.1. So your homework and now, 4B, 4C1, DI final. To the end of till Friday. That's what you're working on for the rest of the time, okay? All right, get onto it because I need to do some checking